Alright, so this video is for the distance formula. The distance formula, we're going to have to be able to find the distance between 2 points, whether they give us the 2 points or 2 points on a graph. The distance formula comes from knowing two endpoints of a line segment, and then subtracting the x's, squaring that, subtracting the y's, squaring that, adding those two differences squared together, and then taking the square root. So for the square root part, we have to either leave it in simplified radical form, but we also want to make sure that we can approximate it to 2 decimal places. Alright, so in red here are the way that I think about the formula and how I apply that to the formula. Alright, so for example number 1, I know that the distance is going to be the square root of the subtraction of the x's. Now you can either go 4 minus 1 or 1 minus 4, it doesn't matter. I'm going to go 1 minus 4 squared. The y's do matter in order, and you have to go from the same x value, its corresponding y value, in that order. So I use this 1, so I'm going to use this negative 3 and subtract from that negative 3 and square that. That tells me that the distance would be the square root of negative 3 squared, which would be 9, plus negative 3 minus negative 3, though that's going to be 0 squared, which is 0. That gives me the square root of 9. I can simplify the square root of 9, and that tells me I have a distance of 3. So that's how the distance formula works. I've got a couple more examples to go through. All right. So the distance formula for this next example, I'm going to take the square root of 2 minus 0 squared plus 5 minus negative 2 squared. This gives me a distance of the square root of 2 minus 0 is 2, squared is 4. 5 minus negative 2 is 7. 7 squared is 49. 4 plus 49 gives me the square root of 53. Now the square root of 53 I can't simplify. So I know that the distance is the square root of 53. But I can also approximate that by using the calculator and taking the square root of 53. Round that to 2 decimal places, or the nearest hundredth, will give me it's approximately equal to 7.28. For a third example here, again, we're still using the distance formula, so distance is equal to the square root of 2 minus 0 squared plus negative 7 minus 1 squared, which will give me a distance of 4 plus negative 7 minus 1 is negative 8 squared, that would be 64. That's the square root of 68. Now the square root of 68 I feel like can be simplified, so I'm going to think about this. I know that 68 is 4 times, is that 17? Yeah, 4 times 17. So I can simplify this, and I should, to 2 radical 17. Not 16, 17. But it's still in radical form, so I'm also going to go ahead and approximate it. When I approximate this, though, I'm just going to simply type in the square root of 68. And that would be 8.25 approximately. So I not only have the simplified radical form, but I also have an approximation. And for our last example here, what if they give me a coordinate plane? Well, it's still really simple. All I got to do is identify the 2 points. I have a point at 2, 0, and I have a point at 4, 1. So the distance formula tells me to take the square root of the x's subtracted, 2 minus 4 squared, plus the y's subtracted, 0 minus 1 in the same order, squared. So the distance is equal to negative 2 squared, which is 4, plus negative 1 squared, which is 1, which gives me the square root of 5. I can't simplify the square root of 5, so in radical form it's radical 5. But I can approximate it. The square root of 5 approximates to 2.24, rounded to the nearest hundredth. On the test, I'm going to have you round these to the nearest tenth. Hope this helps.